So, out of all the events that I do during the whole year, this one is very special for me. So I thank Asan Bhai and all the organizers, those who worked very hard to bring this event. And I'll keep it brief. So I'm just going to keep going because I only have 40 minutes and this session is actually a 75-minute session. So I'll try to cram it within the time I have. So I don't know how the attendees are going to ask me question. So someone can stop me if there is a question from the room, or you can put it in the Teams chat also. I can answer there. So I am not going to talk more details about myself. I just want you to keep a note of my contacts, SQL Worldwide. So after we do this session, if you have any question, comments, if you want to follow up with me, you can send me email, Twitter, LinkedIn, or through my website. Everything works. That's all I want you to remember. Nothing else. And I'm not going to talk about myself because there's really not much time. So I'd rather use the time to talk more technical stuff. Uh, Before I dive into the topic, I just want to make a reasoning that why should you be listening to this talk? What is this intelligent query processing, and why did Microsoft invest so much time and effort into this in the last three release? Pretty much started in SQL Server 2017, and then 2019, and then of course 2022. And Microsoft also has in the roadmap more things are coming in future into this. So we all write queries against SQL Server, we write T-SQL, or we submit queries, or the application submit queries to the SQL Server engine, right? So what happens when we submit a query to SQL Server engine? There are a bunch of phases that the query goes through before we get the result set back, whether, in our Management Studio, Azure Data Studio, Visual Studio Code, or the application, right? Wherever we submit the query from. So the first thing it does, it goes through a parsing phase, right? In the parsing phase, the query tests and see that it can parse into a logical tree, right? And at that phase, SQL Server even does not check your table name, your column name. It just see that logically does the query make sense. So once it passes the parsing phase, then it goes to a phase called transformation phase. And in that phase, the query optimizer actually checks different variations of the tree. So they're all equivalent trees, but it tries to see that can it solve this query in different logical way, right? Because say like if you're using, four tables and if you're joining, then, your join order can vary, right? But at the end, you will get the same result set. And once that transformation is done, then there's something called cardinality estimation. And this is you know, uh, the core of this talk. And this is the main reason that Microsoft embarked into this journey of intelligent query processing because of the cardinality estimation. So in the cardinality estimation phase, the SQL Server try to estimate the number of rows that will flow through each operator. So if you haven't looked at the query plan, a query plan is consists of bunch of operators, right? They're joined together with different arrows or different flows. So in the cardinality estimation, it tries to estimate how many rows are going to get qualified. Now, how does SQL Server do that? SQL Server does it from the statistics. SQL Server also has some hard-coded value heuristics. And sometimes SQL Server estimate the numbers, right? They are not actual numbers. And even if it reads from the statistics or from the index, or SQL Server also can create auto statistics. Remember, in a histogram, you only have 200 data points. So even though you have a table that's with like, say, like 20 billion record, the histogram only has 200 data points. So if anything in between those data points, that, totally an estimate. So once that is done, then SQL Server actually count the cost of each operator. So you must understand that the SQL Server is a cost-based engine. The query optimizer is a cost-based engine. So after that, it sees, it add all the cost of each of the operator, and then it compare the cost. And then when it sees the cheapest one is the winner. SQL Server does not try to go through every possible query plan because then the compilation time will be a lot higher. As long as SQL Server get a reasonable query plan that will give you the accurate result set with a reasonable cost, SQL Server is happy with that. And once it choose a query plan, that plan goes to the plan cache. Now, why does SQL Server put it in the plan cache? So the next time you submit the same query, maybe with a different variable value, SQL Server can use that plan from the cache. So SQL Server doesn't have to go through the parsing, doesn't have to go through the transformation, cardinality estimation, compare cost. So it doesn't have to do the same thing every time, right? So imagine like you go to a hospital, right? Or for a blood test or something. So normally what do? They will ask you first name, last name, maybe date of birth, and then what doctor referred you, right? So for every patient, they do the same thing. So it's the same query behind the scene. It's just your name is changing every time. So SQL Server doesn't have to do this. So as soon as you submit a query, it actually makes a hash out of it, which is called query hash, and then it goes and see if I already have a plan for this query hash and did use this plan. Now this is all good. What will happen if the cardinality estimation goes wrong? As I said, that oftentimes SQL Server has to estimate a number. And if the estimate is really very far from the actual value, then what happens? What is the problem? Now your estimates are wrong, means your costs are wrong. That means that plan with the wrong cost goes to the cache, and then you keep using that plan all the time till that plan get evicted. Now, why a plan get evicted from the cache, that's totally a different talk. We don't have time for that. So till 2017, SQL Server, once a plan is in the cache, even though the engine sees that, yes, my actual number of rows and my estimated number of rows, vary widely, it couldn't do anything. You just keep using it, even though it's bad. Plus, SQL Server has, some of the uh, constructs that are inherently uh, not really very good in estimating number of rows. To give you an example, like multi-statement table value function. Um, and there are, some other table variable. These are really not very good constructs to estimate the exact numbers. And the other thing happen is, even though you update your statistics, we keep changing the data, right? So as you keep changing the data, say like you do insert, update, delete, SQL Server cannot go and update its stats for every change. It's just not practical. So as we keep making change to the data, our stats, our statistics quality goes bad, right? So these are many reasons that why we can get a bad estimation. So what happens when it gets a bad estimation, right? If your cost is wrong, SQL Server can execute a query in a serial fashion or in a parallel fashion, right? Unless you restrict, with your max stop setting. And also there's another setting called cost threshold or parallelism. Both play a role into this. So now if you estimate less, even though the plan could have run in parallel, it is going to use a serial plan, or vice versa. Same thing for memory. So memory grant, right? For certain operations, SQL Server has to grant memory. What kind of operations are like a sort operation, right? Now, if your estimates are low or high, then it's going to give more memory or small memory, right? Or a smaller amount than it needed. And both are risky. If you give more memory, that means your concurrency is going to reduce, because now you cannot give memory to many users or many sessions, because you are giving a lot more than that's not being used. So once a memory is granted, that memory is pinned to that query till that query is finished. Even though it's not using it, it cannot release it and give it to others. If you give a smaller memory, then what happens when you have a sort? The sort is not, there's not enough memory, so now your sort cannot happen in the memory. It's going to go and use your tempdb. So now everything has to be written into the tempdb, get sorted, and then bring it back to the memory. So you're taking more time, and you're keeping your CPUs busy. So again, your concurrency is going to get impacted. Your user response is going to get longer. SQL Server decides whether it's going to do a seek scan or seek plus scan. That also depends on your cardinality estimation. If you estimate a smaller number, it might just go for a seek and then do a small scan. If it's huge amount, it might just do a full scan. That's going to get affected. And then what kind of algorithm is going to use, right, for join, right? It can do nested loop join, hash join, merge join. For the aggregates, it can do stream aggregate, hash aggregate. For sort, as I said, it can do it in memory or TempDB. All of these are going to get impacted based on that. So to solve this problem in 2017, whatever you are seeing that I circled with that orange line, these were released in 2017. I'm not going to read this. These are from books online. You can go and check these diagrams. And then there's bunch more came in 2019, and then more came in 2022. The one in the dark blue, as you can see in the bottom and on the right side of this screen. So all this together, now we have this whole picture, which is a family of intelligent query processing, and these are all color coded, and I just copied this from the Learn website, so you can go and read more about this. Now, some of you might have a edge case that that this some of this feature, most of the time it works out of the gate, right? You do not have to make a code change, so which is another good thing. To take advantage of this, you just have to have your compatibility level up to that, which I'll talk about, but you do not have to make any code change. But if you do not want to, say like you turn, this is turned on at a server level. Now you might have a database that you don't want to use these features. You want to turn on, turn off. There are about 35 of this. And in the system catalog views, you can go and look at this. So you can use this if you want to turn some of these features off for certain database. And you can also do this at a query level, right? So you can also put this as a hint in your query. So again, say you want to turn this on at a database level, but you have some queries that you don't want to use this, some of this feature, you can turn it off. Um, this is a question that I get a lot, that which intelligent query processing features are available in the enterprise edition only. So in my demo code for each one, I wrote this, but sometimes I cannot remember. So this is an URL. I put a question in stackexchange.com and I answered my own question. There you can see a whole list, which will list each feature which is enterprise only and which one you can also use for standard edition. So that's it. I'm not going to go through my slides. There are about 50 more slides. So I'll just tell you, you will get this from my GitHub repo. I'll upload this, and also I can share this to the organizers and they can share it with you. But we don't have time. So I'm going to go into demo, and I'll spend the rest of the time that we have, about 25 minutes in the demo. But I'll just show you how I arrange my slides. So for each of these features that you saw in the slide, for each feature, you will have 3 slides. And each slide on the right corner, you will see these symbols, these 3 symbols that you see on the left side. The first symbol is going to talk about the problem, what problem Microsoft is trying to solve. The second one is how did they solve it? And number 3 is a caution, right? If you want to know a little bit more, there may be some edge cases, or there are some of the things that you should be aware. So that's how I organize the slides. Also, another thing I did, I put the name of the feature, as you can see, like adaptive join batch mode. And when I say 140 plus, what does that mean? So 140 was the default compatibility level for SQL Server 2017. And if you do not know what's the compatibility level, you should start looking at it, because as we will have lot more session today, as the organizers are talking about for Azure, right? So if you go to Azure SQL Database, Azure SQL Database doesn't have a concept of SQL Server 2017, 19, or 2022. In Azure SQL, the only way you can control the behavior of the database is through something called compatibility level. So yes, there is a default compatibility level for each major version, but even though you are in SQL 2022, which is 160, but you can keep your database at a 140 compatibility level. So any database that has the compatibility level of 140 plus, you can use this feature. So the next slide is going to talk about, as you can see on the corner, the symbol. How did it solve this problem? And the next slide is caution, that few other things that you should know. So that's how all the slides are organized, right? So I'm not going to go through these slides. You can read about them because we absolutely do not have time. And so you get all this for each feature. You will be have, you'll have 3 slides. I'm just going to go through at the end. I just want to show you something at the end because I don't think so we're going to have time to come back to this anymore. Uh, I also put some example how you can disable these features if you do not want to use it for a database or for individual query. There are some resources here that you can read more, right? So that's it. So I am not going to talk about slides anymore. I am going to share my management studio. Asan, if you can let me know, or someone in the chat, if you can see my management studio.
Yes, we can see.
Okay, thank you very much. So before all of you came online, I did the setup because this setup takes a lot of time. So you will get this file. I'm not going to run this. Uh, this setup takes over an hour. So, but if you want to run my code, you need to have this setup done correctly. I'm using SQL Server 2022. Um, I was using CU7, but I saw some, CU7 just came out last week, and I saw some weird behavior that I didn't have time to really, see into more detail what's going on. So I reverted to CU5, but the latest CU is actually CU7. I needed a little bit more time, which I did not have. So I'm using CU5. I have to, I really cannot pinpoint why it's not giving me the result that I expected or what changed. But so that's why I reverted to CU5 because I did some extensive test with CU5 a couple of months ago. And recently, last 2 weeks when I was, preparing for this, I saw some different behaviors. So, okay. So I'm also will not be able to go through all this. We only have 22 minutes. So if someone has a particular feature they want to see, maybe put it in the chat or let the organizers know, they can put in the chat. I will jump into that because we'll definitely run out of time. We won't be able to go through all 12 for sure. So I'll just start from one, but if you have any favorite one that you really want to see, I can show you. Just put in the chat or just speak out, then I can jump into any of this if someone has any favorite one that they want to see. So the first one we're going to talk about is adaptive join, right? And the why Microsoft came up with adaptive join. So whenever we join two tables, um, it's the inner join, we put in our T-SQL, but behind the scene, SQL Server has an option. It can do a hash join, it can do a nested loop join, or it can do a merge join. For merge join, there's some prerequisites. I'm not going to get there. So again, what I said, if a plan was compiled with nested loop join, and then you come up with a different value, which qualifies for a huge set of rows, it will still do a nested loop join. Even though SQL Server sees that it's not a good option, but it will do it because that's the plan in the cache. But now there is a workaround, right? So now SQL Server can choose on the fly whether it's going to do a nested loop join or a hash join for the same query, for the same query plan, within the same query plan. So I'll show you that. Oftentimes you will see me that I'll be, even though I'm using SQL Server 2022, which is 16, I am going to revert it to a older compatibility level to show that even though you are not, even though I'm using 2022, but if you are in 2017 and using 140, it will still work. And oftentimes you'll see me, I'm clearing the cache, so I'm getting a new plan, but don't do this in production. You don't want to evict all your plans, right? Then your workload is going to get impacted. A lot of this T-SQL that I'm using, I did not write from scratch. I just want to make it very clear. I copied from here, from GitHub. It says given by Microsoft, and they're absolutely okay. We using it for training purpose, for demo, for our work, whatever. But I did, make some changes, and as I said, I put in each one. This is enterprise only. You can start it from 2017 Azure SQL Database. So each one has all these details. So I'm not going to talk about this going forward just to save time. Okay, so let's go. I also put a lot of instructions. So if you're running this by yourself, turn on your query plan, uh, actual execution plan. So if you do not know what's the execution plan, I really don't have time, but if you are doing any kind of tuning within SQL Server, Azure SQL Managed Instance, you need to know how to read execution plan. Otherwise, you won't be able to do a good job. So, and this said batch mode. So if you do not know, batch mode was introduced first for column store indexes, and then later on it also came for row indexes. So this one is absolutely showing just for a column store index. So let's run this first. So when I say batch mode, um, oh, no, okay, I do not have my. Just give me a minute. I do not have my magnifier turned on. Okay, I'm not gonna. So as you can see here, it says that it's a column store, it's in a batch mode. But as you see here, it says adaptive join, right? It's an inner join, adaptive join, but the actual join type is a hash join here, right? As you can see here, I also have another seek here, but it did not do anything in this case, right? There's no execution of this. It only executed this branch, right? And now, if I insert some fake data, I'm running the same query. This one is 360 and this one is 361. It's using the exact same plan, but look at this. This time, what kind of join I have? Nested loop join with the same query plan. This was not possible before 2017. SQL Server will keep doing the hash join even though you only have 5 rows. Now I said that the batch mode was introduced for column store index, but then later on it came for row store too. So the question is, if I have a row store, can this work, right? That came in SQL Server 2019. Adaptive join, not adaptive join actually. The batch mode was introduced for row store in 2019. So now if I change this to 150, I can still get adaptive join, but you see this is the storage is a row store, right? But I'm still getting a batch mode for a row store. Let me see if I can turn on my magnifier. No. Okay, I'm not going to try that now. Now, does this guarantee that every time you get adaptive join? No. So I'll show you a demo. I'm going to create a store procedure just for demo purpose. Now look at this. I'm calling this first with the 10, then I'm going to call it with the 361. I do not have adaptive join here. The query was compiled with hash join. And next, every time you call that, you're going to get a hash join. If I clear it from the cache, and now if I revert it, so I didn't have a plan, but the first call was with 361 instead of 10. And if I revert this, the first one was compiled with adaptive join, so the second one will also get adaptive join. Okay, so let me know if you have any question. I'm going to create a function here, multi-statement table value function. Functions are good, right? Because we do not have to write this code every time. We can use the functions, so it's more clean. I can change the function definition, but I can keep the function name same, and I don't have to do anything. It has all a lot of good things. But the problem is with multi-statement table value function. If you see in this, I'm going to turn on this. One, two, three, four. Okay. So right here, this also works. Probably I missed something. Just give me a minute. Okay, yes. So I didn't run this. So I'm going to show you a behavior of SQL Server 2016. Right? See, the estimated number of rows is 100, right? And before SQL Server 2012, this used to be 1. Doesn't matter how many rows qualify. Actual number of rows are 114,000, but the estimate is only 100. So what happened now? Look at this. If you see the warning, what does the warning say? It has to write 351 pages to the TempDB because the memory grant was too small, what I was talking about before. Because instead of 114 rows, 114,000 rows, it only estimated 100 rows. So now the memory grant is very small. And now you have all this spills here to the TempDB. And you cannot do anything, right? So now, without changing your code, right? Keep your code as is. We are using a compatibility level of 130. What is this estimated rows, right? So a function, when in the compile time, right? When the query plan is getting compiled, it has no way to know how many rows are going to be passing through the function. It doesn't know. So it's just a wild guess. Microsoft hard coded this number 100. And in SQL Server 2012, P2012, this was just 1. In 2012, when the new cardinality estimator was written, this was changed to 100. And Microsoft knew this, right? That is why now if we see I'm using a compatibility level of 130, now I change to 140. What happened? Now look at the estimated number of rows. It has a right guess, right? So now look at the estimated number and the actual number is exactly the same. And you do not see this spills anymore because the memory grant is high. And there's also a property right here, interleaved execution candidate. So now if it sees a function, it actually stop there, wait till everything else get executed, grab that number, see the exact number of rows that will qualify for that function, and then it will proceed again. And how does Microsoft does this? If you go to my slides, I put some material to read, what are the technologies behind the scene to implement this. Table variable had a similar problem, right? You will see a lot of debate discussion online about using temp table or table variable. And I'm not going to get there, right? Both has its own place, what to do. So just to show you, so now Microsoft is going to, it's called deferred compilation whenever it sees a table variable. So we turn on the actual execution plan. We declare a table variable right here. We do some inserts, right? And then I do a select. This is going to take about 20 seconds. And we are using 140. Look at this. Look at the estimated number of rows. 1. But the actual number of rows is close to 500,000. Same problem. Now we have a sort warning. 6,634 pages were written to the TempDB because I did not have enough memory. And in SQL Server 2019, table variable deferred compilation was introduced. So I'm not going to change anything. Plus now it can take advantage of parallel plan. So I'm just going to change this to 150. I'm going to reconnect, clean the cache, and I'm running the exact same code, no change. I did not do any change to my code. That is not what I expected. Oh, yes. Okay. So look at this plan now and see the estimated number of rows and the actual number of rows are exactly same, right? You get a parallel plan. Also, I do not have a sort spill to the TempDB. Just by using the higher version of SQL Server, or if you are already in a higher version, if you're using a lower compatibility level, use the higher one. Okay, so I think I only have 6 minutes. Is there a particular one that people want to see? You can tell the organizers, put in the chat, because we're definitely not going to be able to use all. So I'm going to continue till I don't, if I don't see anything. So memory grant feedback, right? We already saw that many times that SQL Server, if it doesn't give enough memory, what happens, right? So in SQL Server 2017, there's something called memory grant feedback. for batch mode, and then there were like more improvement happened also in SQL Server 2022. What it's going to do, if it sees a memory grant feedback, it's actually going to persist it in the query store. So even though your plan get evicted from the cache, but it is going to return in the query store. So next time if you have the same query, it will use that memory grant, the bigger memory grant, because it can see in the query store, because query store is actually within your database, right? Query store data get written in your database at a frequent interval. It's not in the memory. It get flushed to your database. So, and then there are more like percentile and persistence memory grant feedback. We'll try to, see as much as you can. So I'm going to clear up my query store, and I'm going to create a store proc. And now if I run the same store procedure with two different values, this one you can see, the first one, it says that you granted excessive memory because it granted almost 67 megabyte. It only used less than a meg. And the second one gave 2200 and then used, 49. So now if I keep running this, the other thing I want to show you, if you go to the memory grant feedback, it says, is memory grant feedback being adjusted? It says no. This is the first time this was executed. And if I go to the second one, it says adjusting, right? And now if I run this again, still adjusting. So if you keep running this few times, it is going to adjust. So if we run this while statement, and if we look at the query store, and I'll stop with this demo, I don't want to take time from the next speaker. So if we keep this running, and now you run this, look at this number. It says 15 meg, right? Next time it increased a little bit, increased again. So it keep trying with a different memory grant. This was not possible before. Everything was static. Once a query plan is in the cache, none of this changed. But now it will keep changing. At certain point, I think after 11 time in my test, it is going to settle down. And this is actually reading from, this is not reading from memory, just so you know. This is reading from query store. So even if your plan get flashed, it can read this data from query store. Okay, I'm going to stop there. We have 2 minutes. I want to make sure that the next speaker get enough time to start. So you see this is still increasing, right? So I'll stop it here. I'll share all this code. I have a bunch more. We are only number 4. I have 4AB, and then we go up to 12. And then I also have 2 more things that I added, not related to this, but can be helpful for people. So I want to, just show you my contacts again. And I want to thank you all. I wish you good luck. And there are more interesting sessions coming. I hope I could watch all this, but it's 1 a.m. my time, so I'm just going to go to bed and enjoy the rest of the day. Thank you.
Basically, we are very happy to get Mr. Toiabl. He's a very fantastic technical guy I have ever seen. I know him personally since 2016. Thanks, Toiabl, for